Alright, so we're going to restrict the domain if needed, like we did on the previous ones. Find the inverse and then verify by graphing both on the same graph. Okay, so now I have x squared, so I do have to restrict the domain on this one because it's a parabola, and the h value is 0, so the vertex is 0, negative 4. So that tells me that the domain for this one is x greater than or equal to 0, okay, because the h is 0. And so now I'm going to go ahead and find the inverse of y equals negative 3x squared minus 4. I'm going to add 4 to both sides. So y plus 4 equals negative 3x squared, and I'm going to divide by negative 3, like that. And so now I'm going to take the square root of both sides. Like that, because I took the square root of the x squared, and you get that. Okay, so switch the x and the y. And then just change the notation. So this is what we got as inverse. So now we're going to graph it. We're going to graph both. So this is what we got as an inverse. Okay, and so now we're going to graph both. And then notice here that what makes the numerator 0 appear, oops, wrong one. What makes the numerator 0 appear is negative 4. So the domain for this one is x greater than or equal to negative 4. So we'll graph it right now. Alright, so I picked the reference points. Now notice I did not use negative 1, 1 because we're talking about the restricted one where all x have to be greater than or equal to 0. So that's why I started with 0, 0 right here instead of negative 1, 1. I added an extra point, 2, 4. And how I got that point, remember I told you guys when you have y equals x squared, I just put in a 2 right here, and 2 squared is 4. And that's how I got the 2, 4. So, this part. So now let's go ahead and calculate. Notice the x does not change because b is 1 and h is 0, so x does not change, so that stays 0. Negative 3 times 0 is 0, minus 4 is negative 4. The x does not change. Negative 3 minus 4 is negative 7, and then 2 doesn't change. Negative 12. So this number is too big, so I'm probably not going to graph it anyway. Okay, so let's put it on a graph. Okay, so let's go ahead and plot the points for f of x for the restricted one. So I'll use pink. So 0, negative 4. And 1, negative 7, and that's as much as I'm going to graph because 2, negative 16 is off my chart, so I'm just going to graph that. Remember, it's the left side, it's the right side of the parabola that's opening down. I'll change the color, and remember how we graph inverses, how we switch the points. So instead of 0, negative 4, we're going to do negative 4, 0. Instead of 1, negative 7, we're going to do negative 7, 1. And it goes like this. Okay? And if we draw the line y equals x, the pink and the blue will reflect or be symmetric over this line right here. Okay? Alright, so number 10 does not need any restricting of the domain because it's a cubic function. So we're going to go straight ahead and switch the h of x to y. We want to find the inverse first. So it's going to be x cubed plus 3, so we subtract 3. Because remember, your goal is to leave x by itself. So now, to get rid of the 4/5, we multiply by 5 over 4. And I'll just put it over here on this side. Let me put parentheses. And then we have to do the same thing over here on the left side. So 5 over 4. Don't forget, it's 5/4 times both y and the negative 3. So now, x cubed is by itself, so we need an x, not x cubed, so we're going to take the cube root of both sides. Okay, cube root of both sides. So that eliminates the radical on the right side, and now x is by itself. since x is by itself, we can switch over the x and y, so let me put the y by itself over here. Cube root of 5/4 x minus 3. So I switched the x and the y already. So the inverse would be cube root of 5/4 x minus 3. Okay, so this is what we have as a cube root. So now we're going to graph both of them on the same graph. Alright, so here we see the reference points for the cubic function, and along with the transformation that is going to occur. Nothing happens to the x because b is 1 and h is 0. So we just copy the x, and then 4/5 times -1 is -4/5. When you add 3 to that, you get 2 and 1/5. And then 0 stays 0, 4/5 times 0 is 0, plus 3 is 3. And then the 1 stays 1. And 1 times 4/5 is 4/5 plus 3, 3 and 4/5. Okay, so now we're going to plot these points. Alright, so let's go ahead and plot the h of x function. So -1, 2 and 1/5. So that would be about here. And then 0, 3. And then 1, 3 and 4/5. So that would be about here. So it's a cubic function, so we know that the points go this way, up and down, like that. So this is h of x. Okay, so now we're going to graph the other one. I'll use blue for that one. And so remember, we're just switching the points, the x and the y, so 2 and 1/5, -1. So approximately right here. 0, 3 becomes 3, 0. And 1, 3 and 4/5 becomes 3 and 4/5, 1. So that's approximately right here. Now this is a cube root function, right? Because it's h inverse of x, so it goes this direction and this direction. So if we were to extend them, we would see how the arrows here would meet at the line y equals x. If we were to extend it a little bit more, we would see that they would meet right at that line, and as you can see, they are symmetric over that line. And if you check the points here in this equation, they will all work out. Alright, so you're graphing the function, stating the domain and range, and then behavior, okay, or in behaviors. So here we see that h is 1, so it's going to be x plus 1. And a is -3 and k is 2, so it's going to be -3y plus 2. And we're going to do the transformation on these points. So 0 plus 1 is 1. -3 times 0 is 0, plus 2 is 2. 1 plus 1 is 2. -3 plus 2 is -1. And 4 plus 1 is 5. -6 plus 2 is -4. So we're going to plot these points. Okay, so 1, 2. So that's where the dot goes. 2, -1, and 5, -4. And that's at 5, -4, that's where you draw the arrow. Okay, so connect, and then there's the arrow. For domain, remember domain and range for square root functions you get from h and k, and from the picture too, from the graph, but h and k are the numbers that we're going to be looking at. So the domain is, and they wanted in, let me see, they wanted in interval notation, so we want all numbers greater than or equal to 1. So the domain's going to be from 1 to infinity. Bracket on the 1 because it includes the 1. For the range, you go from the bottom to the top, okay, and from the bottom you get an arrow, which is pointing down, right? So you get an arrow and you go up, 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 up until you get to 2, and that's the last y value on your graph. So it's from -infinity to 2, because you always go from the smallest number to the biggest number. That's why you write -infinity first. Okay? and that's your domain. For end behavior, we say as x gets bigger, because notice how it's going to the right, right? It's going down and to the right. So we say as x goes to infinity, the y, or f of x, goes down, goes to negative infinity. Okay, so number 14 is a cube root function, so I have the reference points right there. I added the 8, 2 just for as a security blanket. And did I copy it right? Yeah. Okay, so now b in this problem is 1/4, so then we do the reciprocal, so that would be 4. And h is negative 2, so it's 4x minus 2. So there's a big horizontal stretch on this one. And the y's, we're going to do y minus 3. Okay, so we transform the points. And so negative 4 times negative 1 is negative 4, minus 2 is negative 6. Negative 1 minus 3 is negative 4. This next one's going to give me negative 2, negative 3. 1 times 4 is 4, minus 2 is 2, and then 1 minus 3 is negative 2. And 32 minus 2 is 30, so we're definitely not going to graph this point, but it helps you direct you in the right direction. It's going to head you in the right direction. Okay, so now we're going to graph. Alright, so for negative 6, negative 4, okay, negative 2, negative 3, and 2, negative 2, okay, right here on this side. And then the next one would be 30, negative 1, so it'd be like way over here somewhere, right? So that tells me that the graph is going to go like this instead of like this. Okay, so there's a small little curve right there, and then a small little curve this way. Remember, this is your inflection point right here. That one's your inflection point. Okay, so domain and range. Well, the nice thing about cube root and cubic functions is that the domain and the range is both all reals, but they want the answer in set notation. So we're going to say all x such that x is between negative infinity and positive infinity. So it's all reals. And for the range, y such that y is between negative infinity and positive infinity. Okay? Oops, forgot the brace right here. And then for end behavior, we say as x goes to the right, notice how it's going up. It's very subtle, very slightly increase on the right, but it's still increasing. So f of x goes up. And as x goes to the left, notice what's happening at the left. The graph is, again, very subtly, very slowly, but it is going down. So we say the y is going to negative infinity. Alright, so number 16 is another square root function, so there are the reference points for square root. I'm going to, let's see, b is 1 and h is 3, so that means that it's going to be x plus 3. And a is 5 and k is 1, so that's going to be 5y plus 1. So we're going to now transform the points, so 0 plus 3 is 3, 5 times 0 is 0, plus 1 is 1. 1 plus 3 is 4, 5 times 1 is 5, plus 1 is 6, 4 plus 3 is 7, and 5 times 2 is 10, plus 1 is 11. Okay, so that last point is a little bit too high, but we'll still plot it. Alright, so 3, 1, 4, 6. And see, you could see that how far apart they are because it's a vertical stretch by a factor of 5. And 7, 11 up here somewhere. So 3, 1 is the dot. 7, 11 continues with an arrow. Okay, so here's the graph. So for domain, remember h and k give us the domain and range for square root functions. The h is 3, k is 1. And we could see it on the picture also. This one they want you to put it in inequality notation, so we're just going to say that x is greater than or equal to 3 and y is greater than or equal to 1. Okay, there's your h here and there's your k right there. As for end behavior, this only has one arrow.